Okay, welcome to the Foragecaster webinar, hosted by AgriWebb. We've got some special guests with us. We see a lot of people filing in right now. We have with us today Ash Rootsey from Food Agility. We have Phil Tickle from SIBO Labs, and we have Rob Waterworth from Flint Pro. Okay, now remember that there's the chat available in the Zoom, and you can ask questions as well. And we'll have some time at the end to get into questions.
A few people streaming in, Kenny, it's great, but 46.
Everyone's very punctual today, very punctual. Good to see. All right. We are going to set up a poll as well to see what software you're using, or if you're using software at all. There should be the poll in the Zoom toolbar there. All right. Looks like you guys have all done this before. Okay. We have hit 50 people. I think that's a great time to start. So far, out of the audience, we are sitting on 62%. Are you currently using AgriWebb, the SIBO Labs or Flint Pro? Good to see a lot of the producers on the call today. Okay, so today's webinar is introducing Foragecaster. It's a farm sustainability planning and forecasting, and it's a collaborative project with multiple industry partners, research institutions, and assistance from the government as well. So we'll start with an introduction, and I'll then hand over to Ash from Food Agility to talk about how Food Agility and the CRCs work. I'll then go into a detailed description of Foragecaster, and then we'll hear from Phil about how SIBO Labs are working with the project, and also from Rob on how Flint Pro are involved. And we'll have some time at the end for some Q&As. So you can enter them in the Zoom as you are listening. So first up, a little background. So I am the first employee at AgriWebb after the founders. So I've been here nearly 8 years in a few weeks. When I started, I was head of engineering for the first 6 years. And over that time, we were focused on the customer acquisition, and we were focused on building out all the features to be able to help the producers being able to record all their information. At the start of last year, I addressed a gap that I believe we have. And that was while we got very good at capturing all the information, and we started doing integrations with the satellites with SIBO, and the water monitoring with different IoT providers, and manual entry that farmers will need to do to cover all the records happening on farm. The farmers wanted to be able to use this information to be able to help them make better planning decisions. So what was the purpose of recording all this information? They wanted to make good use of it. Also, there was a whole lot of research going on in both throughout agriculture, both in livestock and pastures. But this was quite orthogonal to our development. We didn't include any of this research in our product. So last year we formed this new group, the R&D group. And this is to help foster collaboration. And that's with what's available coming out of the government, the industry bodies, the research institutes, the integration partners, as you may have seen our marketplace being launched, and also the universities. I will now hand over to Ash to talk about food agility.
Thanks, Kenny. And g'day, everyone. Thanks for jumping on. Really appreciate it. So I'm Ash Rootsey. I'm the AI and robotics lead at Food Agility CRC. And so I can talk a little bit about up the top about, first, what is food agility? And then also what's the sort of process we've gone through so far with each of the partners on the project to bring together the Foragecaster initiative that we'll hand back to Kenny to dive into for the bulk of today's presentation. So Food Agility is a cooperative research centre, the CRC, that delivers research and innovation services to the Australian agri-food sector. We specialise in projects that use technology and data to help increase profitability and improve sustainability of national food and fibre systems. So we are a national body. We work across a lot of different verticals within the agriculture system, so different value chains, very different commodities. We also work in projects that go up and down through those value chains. So we have projects that look at on-farm inputs and demand planning for farms, on-farm trials, sort of post-farm processing and food distribution, right through to retail and consumption as well. So a lot of different lessons we've been able to take from a lot of different projects across our portfolio. So generally, as a process, Food Agility has 4 steps that we run through with all of our partners, which is something we've run through very similarly in the Foragecaster initiative. So firstly, we'll work with our partners to identify significant industry opportunities that may be addressed by technology or data and using those tools in new ways. We then bring together diverse teams from industry, tech, research, and government to start to address these opportunities or some of these challenges. We then helped co-design innovative, impactful projects that match the top capabilities from each of our partners. And then fourthly, once the projects are up and going, we then support the facilitation of agile project delivery in these applied research areas that's dynamic, commercial, and scalable for maximised local and global impact. So on the next slide, Kenny, you'll get to see a little bit of a smattering of some of the partners we have worked closely with at Food Agility. As you'll be able to see from the slide, number of major Australian agribusinesses, representing a number of the key commodity groups, also a number of the leading technology providers, both local sort of in the Australian startup ecosystem and multinational tech companies as well. Also a lot of, a number of Australia's leading universities, both in the technical domains and also the agricultural domains, as well as, another number of other industry supporters, state government bodies, federal government bodies, all of which we work very closely with in trying to address some of these major challenges for the sector. We'll go to the next slide. Thanks, Kenny. So me personally, I head up the AI and robotics pillar, which is a sub-branch of the broader Food Agility portfolio. Here on the screen, again, you'll be able to see a number of the different areas where this technology or these 2 technologies are starting to change the game in the ways in which we produce our food, and also, we tell the story about how we produce our food and, expand that into global markets. So yeah, a range of examples you can see from animal welfare in the pork industry through to robotics in viticulture, monitoring of food safety in shellfish, detection of carbon in rangeland, northern farming systems, right across through, a lot of different predictions around harvest timing and quantity, quality in horticulture, as well as, looking at the ways in which all of this data can be collated and most importantly protected and kept secure, so that we make sure that it's, the integrity of our farming systems data is maintained throughout. We can go to the next slide. Thanks, Kenny. And so that sort of is a good segue into what we've been working on so far in the Foragecaster journey. So as you can see, we've worked very closely with Phil, Kenny, and Rob, and their organisations from the industry side. We've also brought in leading minds from UTS and QUT. From UTS, we've worked with the School of Design and the Transdisciplinary School, as well as the Data Science Institute, and QUT, the School of Mathematical Sciences and the School of Information Systems, to sort of cherry pick the best sort of opportunities and the leading minds from each of those fields, to apply them in what we're about to learn in the Foragecaster initiative, which we're really excited about and are looking forward to supporting in the future. So I can hand back to you, Kenny. Thanks for that.
Thank you. All right, we'll get into describing what a Foragecaster is now. So it comes back to this burning question, and that is, how do we feed 10 billion people without using more land while lowering emissions? And we all have to do our part. There's no silver bullet. And, you know, our focus is in the livestock area. But it comes down to we just have to be more efficient. We just have to be more efficient, and we have to take sustainability into account as well. So on our path, on our journey so far with AgriWebb, we focused on the record collection. And to do that, we wanted to be able to digitize the livestock data, starting at the farmer. To make the information available, we had to do a holistic management platform to cover all the different records that are happening on farm. To make it a benefit for the farmer, we had to make an intuitive visual interface, so then they'd be able to enter in the information without it being too much of a hassle or a drag or too complicated. To handle working in regional Australia, we had to make it work offline as well. So it works on your mobile, you can do it out in the fields. When you come back within range, it will automatically sync to the cloud, supporting multiple users as well. So 8 years ago, we started with this mob-based product. About 2.5 years ago, we released the individual animal product. And this allowed the next level of accuracy and traceability throughout the farm. So what we're seeing here is the individual weights of a farm, and you can see the customizable filters up the top. So you can really drill down and analyze your information. We hook into all the different hardware that happens at the crush level. So the weights can automatically be sent up. You can set up templates to say, I'm doing a treatment and a score as well. So we work in the process that the farmer, the producer is working at the crush. So to understand the current situation, we are getting requests, and these can be from at the progressive producer level, but importantly also at the larger group as well, the corporate farms. They really want to know what are their sustainability metrics. So, and this is getting pushed from multiple areas. The shareholders, the enterprises are needing to address, and also the consumers are asking for it as well. But also from the producer's point of view, they need to know how they can keep their land in the best condition to pass on. So we need to be able to accurately forecast supply. So as I mentioned, we were focused on the record keeping. In the cases where we had to understand what a future weight would be, we'd just get the last 2 weights and project the line forward. Or you'd type in an average daily gain and would project the line forward. But as you know, nothing really grows in a straight line. The grass doesn't grow like that. Humans don't grow like that. And especially livestock doesn't grow like that. They all grow in a beautiful natural curve. So all this research is available. We need to make that available for the producers. From the producer's point of view, they need to know when to sell. You might have a dry period coming. You might know that everyone else is going to be buying the feed as well, external feed. Where is the maths behind, should I be selling early and cutting my losses, or should I be buying the external feed in? There's a lot of things to take into account there. Like, are you focused on keeping your genetics, or are you worried about the bottom line? So what's been changing? There's been developments in weather forecasting. This is something that improves year upon year. It's using new techniques like the machine learning and so on. There's new players on the market and new products on the market as well. And this is definitely not a crystal ball. We're not going to rely on this to be able to say what the weather is in 4 months exactly. But what it does offer is a probabilistic data set of what the weather could be. Once we got some numbers, then we can run through all the different scenarios. So we can understand the effect of what does it look like when it's dry on your farm? What does it look like when it's wet? How would your plans change between those two? So as I mentioned, like livestock research is very important for Australia. and there's some great stuff going on, but we need to give it more exposure. Often it would be the final output may be like a research paper, or it may be a single purpose website that the farmer has to go in and create all their data on, a new username and password for this one purpose that, you know, it may not get a lot of use over time. How can we integrate this livestock, this research, into their everyday processes? And lastly, over these years, we've been collecting this large warehouse of over 60 million animals. And this is data that the research world hasn't seen before, where we got, you know, detailed, accurate information about the animals, you know, characteristics, pregnancy, weights, you know, all the pasture types they've been eating, all this information. What can researchers do with this? And the privacy of the information is paramount. We're not exposing any personal information. We're not even exposing geolocations. But it is, it's going to be a gift to researchers to see what they can come up with. Imagine we could give a company the sustainability metrics now. The next question they'll ask is, hey, I know I'm buying animals in 2 months, or I know we're going into a dry period. What do we have to act now to maintain our sustainability targets in 6 months? The idea is to create a livestock supply forecaster. So this is using the best of breed domain models together with machine learning. And so what are these major components we're talking about? We want to understand what is the best weather forecasting, the seasonal forecasts in regional Australia, be able to feed that into understanding a probabilistic output of what the pasture growth will look like through machine learning. From there, we can get a probabilistic output of what the livestock growth will look like. We can analyze the feed costs, how it's gone over time, historically, in relationship with the weather and other pressures. So we could predict the feed costs of buying external feed for the next 6 months. All of this can go into the decision maker to help the farmer decide whether they should be buying, selling, or keeping, with scenario planners, basically making a digital twin of your farm so you can try different scenarios out. And along with this, we'll be getting the sustainability and resilience metrics. So we can understand the effect and the relationship between the farm's performance and resilience. Now, here's a very rough diagram of what I said in boxes. So starting in the future weather, going into the pasture, going into the livestock. But I'll cast your eyes to the far right here. These are the main outputs of what we're thinking for the producer. So there's a scenario planner, and that's providing this digital twin that allows you to understand the financial impact of your farm for different scenarios. For example, buying animals in 2 months. The grazing planner will take all the future weather scenarios into account, and this will help you make your management decisions of where am I going to move my animals next for the different weather patterns. With this, we'll be able to understand the livestock availability at sale weight, plus the aggregated sustainability metrics, both at the farm level and also aggregated at the supply chain, enterprise, or corporate farm group. So for the research for Foragecaster, we've broken it into 4 separate areas, each with their own sets of academics, but working together as well. So we have pasture growth, and from there they're working with SIBO to understand, excuse me, if we can look at the satellite information for the last 7 years and to be able to do machine learning with that and the historical weather, how can we forecast it into the future? Another area is on pasture quality. Currently, a lot of the remote sensing technology is focusing on the quantity of feed. And we realize the key thing that's missing is the quality of this feed. And that's understanding the pasture classes, the pasture types, the flowering state, to really understand the digestibility of it, to understand the true metabolizable energy. There's another stream focused on livestock growth. So they're going through our large data warehouse and being able to understand how all the different criteria are affecting its livestock growth. What does it mean when they have treatments in the first 6 or 12 weeks of birth? Does it affect its livestock age? How do all the breeds and the different locations differ for the livestock growth? We have the sustainability metrics as well. So this is where we're looking at different layers of sustainability, whether that's biodiversity, the carbon sequestration or emissions, and there's more layers we're bringing in as well. And not just understanding it now, but how are you projecting that into the future? We can also understand the relationship between these 3 things: resilience, production, and sustainability. For example, we could analyze the New South Wales drought and try to cluster the farms, try to understand the farms that bounce back better than others. What did they have in common? Surely access to capital will help, but did they sell early? Did they have natural grasses? Biodiversity on farm? What were the key things that helped them bounce back better? And finally, the planning tool stream. And this is where we're building on the simulations and the optimizations for the grazing planner and the scenario planner. We'll also be able to provide regional benchmarks of all this as well. I will now ask you to, we'll launch another poll, and how data-driven is your grazing decision-making at the moment? And I will hand over to Phil as you're doing your poll, and we'll get the results of it in a few minutes. Just, I think we've got to get you off mute there, Phil. My lip reading's pretty good though.
Have I got to unmute myself, do I? Okay.
We got you, we got you.
Sorry.
All right, over to you.
Okay, yeah, good afternoon, everyone. Thanks for joining today. And it's a great pleasure to be working with AgriWebb on this project, and we're working with AgriWebb on a number of other projects as well. So I suppose just before we get into the specifics of the project, just a quick snapshot of what SIBO Labs does, if you haven't heard of us. Dr. Peter Scarth and myself founded SIBO Labs back in early 2018, and it was really on the back of a decade of a lot of frustration around the lack of adoption within the livestock industry in the ag tech space, and particularly the remote sensing space, which is where we had a particular expertise. And so we've spent the last 5 years building a business to support largely the livestock industry, and we've got a wonderful team with the business now. We've got about a dozen people working on things within the business, and growing quite rapidly across a whole range of things. But I suppose in terms of the activities we're working on at the moment, our core business is really around pasture monitoring, and we're doing that basically at paddock and national scale, and I'll show you some more of that in a minute. But around that, there's a whole range of things that is happening, which is really changing the ag tech landscape. So while we're working at paddock scale, we're also working with the Australian Beef Sustainability Framework on their industry reporting systems. We're doing work around benchmarking, and I'm going to show you some examples of that in relation to this project in a minute. We're working with the likes of Ceres Tag, tracking animals around the paddock. We've got farm mapping systems we've developed. We've got data collection systems on the ground we've developed, and we're working with long-term research projects. In particular, the Rangelands Carbon Project is one in particular, a $6.5 million investment, about $2 million coming from Australia's largest cattle company. And I think the other thing that's changing as well is both the need and the necessity for companies to work together. So we're doing a lot of work with AgriWebb, integrating our applications, and with the likes of Pear Tree and FarmBot, AgriWebb, and MLA, we're doing a lot of work to integrate our technologies to make it easier for the producer. So that's really a cornerstone of basically of the way the ag tech industry is sort of moving ahead now. And at I suppose at the other end of the spectrum, a company like SIBO Labs, we've collected we're currently providing about over 60 million hectares of individual paddock level pasture biomass services every week, and we've collected sort of something over 6,500 field sites now, even about over 1,500 in the last 12 months. collecting physical pasture estimates on the ground. So there's a lot going on, but the focus of this is around that pasture piece in the middle there and how it connects to those other capabilities. Next slide there, Kenny. So in terms of the work directly related to this project, there's a couple of things I just wanted to point out here, but we are working with AgriWebb right now at paddock level, and we've got quite a number of producers and working directly with the marketplace. You can come along and buy a CBLab subscription directly out of AgriWebb's marketplace now. But what it boils down to is paddock level estimates of pasture biomass. So those images on the top right there, that's showing as of a few days ago. That was the 9th of May for an individual property. The variability in pasture biomass. This property is actually near Canowindra or Canowindra, Canowindra, and you can see the variability in the pasture biomass across that property. Those purple areas on that map are over 4,000 kilograms of dry matter. A lot of those areas are hayed-off pasture, so fescue and phalaris pasture that's hayed off, so relatively poor quality but high biomass. And on the right-hand side, that top left-hand image there is showing you basically just those paddocks there. You can see the high biomass paddocks through the in the middle of the screen there, high biomass, but they're actually obviously hayed off. So you can see there's lots of variability in pasture quality there as well. So that information feeds directly into AgriWebb through an API. So an AgriWebb client can basically load up their farm, and within about an hour, actually usually less than an hour, they're seeing estimates of pasture biomass coming into their feed calculator within AgriWebb. And on the bottom, in the middle there, you can see that little graph. We're doing things around cloud detection, cloud shadow detection to really improve the quality of the estimates of pasture biomass in cloudy periods, and then feeding that straight into AgriWebb. Now, the critical thing here is that while at the moment the CBLab's Pasture Key service is a point-in-time snapshot, every 5 days you get the best estimate that we can provide based on 5,000 to 6,000 field sites. We're giving accurate estimates of in the order of plus or minus 10% accuracy, so 200 to 400 kilograms per hectare error over a 2,000 to 4,000 kilogram estimates. But we're only giving you the snapshot of today. And what this project is doing is to provide the ability to downscale the seasonal forecasts and to drive that to paddock scale. Now, when we've got weather data at between sort of 3 and 5 and 20 kilometre resolution pixels, that farm that you're looking at there, which is probably about 1,000 hectares, that's basically one pixel in a weather map, and we've got 10 metre pixels in there, and the actual effective rainfall given runoff and slope and aspect and other things, there's enormous variability in pasture growth rate at paddock scales that is never represented in effectively in anything to do with a weather scale pixel. So this project is basically about downscaling that coarser resolution information, integrating it with machine learning into the near real-time pasture biomass, and then generating forecasts of pasture growth at sub-paddock scale to basically grow those pastures on in terms of their variability in pasture growth actually across the paddock. So that's a really key. That's going to be a very, very new capability. Now, importantly, then at an industry scale, we've been working with MLA with the Australian Feed-Based Monitor, which was launched on the 30th of November. We've now got over 1,800 new producers using this system, and it's providing whole of nation, every farm in Australia, every 5 days is getting a rolling 30-day estimate of pasture biomass across their land parcels in their farm. And you can come in, if you're a levy payer, you can come in and get access to that. And one of the major outcomes of this project is not just about providing that individual producer estimate in a private environment, and it's really important to I suppose emphasise that this is actually all being done within a very secure and very private environment, but to also provide that synoptic view of what's happening across the country. And so a lot of the knowledge that's coming out of this project at farm scale is then going to be sort of rolled into these national capabilities where we can start looking at seasonal forecasts across large regions. And if you're looking at agistment and those sorts of things, you can then look around your property and then look at basically where you might go and agist cattle, or people might be able to sort of to know areas that are being flooded, areas that are being affected by rainfall or frost or whatever it is, to provide that synoptic view as well. So there's going to be enormous power in that predictive capability going forward. Next slide there, Kenny. Now, the second piece of this work is really around the sustainability piece, and we have we already have been doing this work for a number of years within SIBO Labs. So we're currently benchmarking properties around ground cover. If we look at the top right slide there, that's basically showing you the range of ground cover levels of the neighbouring property, which is I was showing you a minute ago with the pasture biomass, and you can see it's highly variable. You can see the seasonality of the ground cover in there, and you can see that blue line, which actually is shifting the ground cover, where the ground cover on that farm relative to the neighbours is changing. So it's gone from being highly variable. Then in about 2013, the variability of that ground cover started to tighten up. And then you can see as the drought broke in 2014, 15, and we had basically more than 5 years of drought, as everyone else's ground cover levels are dropping, that property's ground covers is not dropping at the same rate. And if we show to the graph at the bottom there, that property there is showing basically the relative ground cover levels of that property compared to its neighbours. So you can see there in about 2008, it bottomed out. Its ground cover levels dropped below the levels of its neighbours, and then it's actually climbed out of that, and it's gone from being in the 50% pack to basically up in the 90th percentile. This property changed from basically mixed farming, from cropping and grazing, a highly volatile enterprise, lots of issues around the family business. They shifted into rotational grazing, and you can see the impact of that basically on that graph in terms of when they changed their management. So this project is actually going to be taking that sort of benchmarking several steps further, and also into that forecasting space to be able to not only forecast today, but also to be able to forecast based on land condition and weather conditions, what that future land condition state or natural capital state might be, given a range of management activities. And I suppose another example there is the forest cover. We're already doing work with around the supply chains at individual farm level, as well as across entire supply chains, looking at things like deforestation-free beef and carbon sequestration. And then on the top left there, we've got an integration with Flint Pro, and Rob will go into that in more detail in a minute. But that's actually already providing forest carbon estimates on farm level and then across broader regions. And this project's going to be going into far more detail and be looking at habitat assessments, biodiversity assessments, and biodiversity forecasting, as well as the carbon forecasting. So really exciting stuff to take this existing capability from where it is now and then really supercharge it into future forecasting at much higher resolutions. I'll leave it there, Kenny.
Thank you, Phil. All right, about to jump to Rob from Flint Pro, but we'll go through the answers of the poll. We have how data-driven is your grazing decision-making process on farm? And 74% is make day-to-day decisions based off farm observations and weather. We have 6% using a fixed grazing calendar, 6% that are using SIBO Labs Pasture Key, and 14% that are using Excel. All right, thank you, Amber. All right, now we'll go over to Rob from Flint Pro.
Thanks very much, Kenny, and hi everyone. We can see a few familiar names in the attendees list, which is fantastic to see. So, but for those that don't know about us, I'll start off by saying how thrilled we are to be part of this project. It really does play very much to our strengths and the things that we like doing. And the key piece of that is collaboration and working with fantastic groups with interesting data that we can actually pull together and start delivering really useful solutions. So thanks again to Food Agility, obviously AgriWebb, SIBO, QUT, and UTS for this. So, but anyway, look, for those that don't know, Flint Pro is a software package that integrates multiple streams of data to produce metrics about our land sector. We've worked in this space for a very long time. I've been working in the carbon accounting space in the land sector now for 25 years, which is somewhat disturbing in some ways. But what we really do is we look at bringing together multiple different streams of data, combining them with models, and then producing the results out the back. So taking, and Phil's mentioned that before, for example, taking remote sensing data from Phil and how do we integrate that with models to provide information like soil carbon or better forest carbon estimates. So the key piece for us in this is how can we start doing better on the sustainability metrics? Now, sustainability metrics are a very complicated area. It's fantastic that we've got some universities working in these as well to help us through this space. But one of the key things for me that we often see with sustainability metrics is organizations want fewer metrics because you don't want to have pages and pages of them, and researchers and groups like ourselves like coming up with more metrics. So there's a dichotomy there that's starting to happen, and it's a matter of how we're going to pull that back together into a really sensible set of data, and that's a really exciting piece of this project. So at a very high level, I thought I'd start by just listing some of the metrics that we're looking at now and how they come together. The starting ones are obviously land use, land cover analyses. There's plenty of those around. We will often say best available data. Best available depends on what you're trying to do, but there's the national data sets. There's really strong partnerships that provide much higher quality data than that. And that is clearly where SIBO fit in, but also the ability to start getting on-farm information about these, where the satellites aren't probably picking up quite enough at the moment. And so this is where the links into AgriWebb work really well. They really do sort of drive a lot of the other metrics. I think that's a really key thing to remember, is that what you're doing on your land, how you're using it, what the cover is, as Phil's pointed out, it is going to drive a lot of the overall metrics in the end, no matter how different they are in their titles. The greenhouse gas emissions and removals, I won't go into that too much. That's obviously a pretty stock standard thing, although scaling it and getting it working is extremely difficult when you're going from individual farms up to very large areas, but that's pretty much our bread and butter. Around doing full farm accounting, carbon stocks, non-CO2 emissions, etc. But what I think is really exciting about this project is the right-hand side of this slide, which is really starting to look at that risk adaptation resilience issue, and like how do you actually put these climate change scenarios into not just the forecasting for your forage, and but also what's the forecast for the sustainability of those, and how do you change your management practices? Most importantly, how do you then link it to farm planning? And I think that's the exciting piece in particular with AgriWebb. It's not just about being able to say how sustainable, how are we and how much have we improved, but how can we improve even more? And how can we actually support people in those decision-making processes? And then obviously looking at the next set of sustainability metrics, and this is really working with the teams at QUT and UTS on looking at different ways of doing biodiversity at different scales. Biodiversity is very complicated and it's got a lot of different meanings depending on what you're trying to do. And so this is a really interesting piece of how do you use these different tools and methods to get to biodiversity at the right scale and the right meaning. Looking at water use, quality, quantity, runoff, erosion issues, for example, and chemical use, be it pesticides. I should also put down here, obviously, fertilizer, all of those types of things. So these are the sorts of metrics that we're really starting to build in as part of this project. I'll grab the next slide, Kenny. Thank you very much. So this is just a very high level diagram of how Flint Pro works and where we kind of fit in this piece. If you're looking at the volume of work, the diagram looks quite different. I've just put us in the middle to show it. We're not actually the only huge piece in the middle with these other bits on the side. It actually looks quite the opposite when you look into the program itself. But you can see on the left-hand side outside the grey box, we have all of these extensive environmental and data input variables that need to come into a system. And this is where these the key partners here are vital. Our role is really in this middle piece. How do we take all of that data? How do we attach and create models for those and then start producing the outputs? So things like Phil was showing, how do we produce these high resolution spatial and temporal outputs that we can then store and start feeding. And then outside the grey box on the right-hand side, again, comes back to the SIBO and AgriWebb teams. How do we display that? How do we do that reporting? How do we actually engage with people and that farmer-facing part of the work? So we really are sitting here as an engine piece to be driving in on these sustainability metrics. Thanks, Kenny. Just a couple of quick examples here of what the engine produces already, and just some examples. So obviously vegetation carbon, we do a lot of that. That's a full replica of the national system running at a nominal 25 metre pixel across the entire country. And we can do all the projections for reforestation, HIR, all of those things inside that, consistent with the national systems. More importantly, we can also upgrade those national systems. So I think it's a really key piece to think of, especially with the forest cover maps, but also the biomass maps and the biomass and carbon estimation models that underpin. They can definitely be vastly better at the farm level if you have better data. And so AgriWebb and SIBO really come in and you can start to really tune these systems as needed. That's a really exciting piece of this work. There's the soil carbon work, of course, where we have soil carbon models. Soil carbon models are great, but you need to drive them with something sensible. Hence, again, the inputs from a group like SIBO Labs to help drive those, and obviously the management data from something like AgriWebb. So it all comes back to this data integration piece. And then quickly on the right-hand side, looking at the future carbon risk. So this is just a really quick example of the sorts of things that we've been looking at already. This is a map of potential forest carbon stocks and existing forest carbon stocks down the bottom through time, but you can start intersecting that with things like forest fire danger index days. So yes, you might want to put a whole lot of additional forest in here for some insetting or some offsetting programs, for example, but what's the risk of that? What's the additional risk of that by 2050? That's something that we really need to start thinking much more about. And you can start integrating those, especially with these future forecasts and everything that are coming through this project, to be able to say, here's some solutions, but hey, in the next 20 or 30 years, it's actually going to change the risk profile a bit from what you're seeing here now. So there's some good examples of where we're running already. Kenny. And finally, I think I'd sort of stop on what are we trying to solve here? And what's the complex parts? And some of these are not going to be solved as such. They're going to be something that just needs to be continuously refined and watched because they're always moving. So I've tried to break it into 4 key areas. I've got a lot of text here, primarily because I thought there would be people who might be quite interested in asking questions about this or coming to us. I'm not going to read it out word by word and bore everyone, but we break it into the 4 areas. One being the policy and reporting drivers of why we're doing this. Probably in many ways, actually, the thing that's in the most flux at the moment and will be for a number of years. Not just how domestically in Australia we're going to deal with all of these new requirements for sustainability at the markets, but we're also subject to all of that overseas, especially where we're exporting. So you have a really interesting landscape around there. And also the guidelines that are all still being written. For example, the World Resource Institute Greenhouse Gas Protocol guidelines are only now out for field testing at the moment, and they will probably be picked up by a lot of groups. So really important to be keeping an eye on that. The second part is clarifying and supporting the input data processes. There is a lot of input data to these systems. It comes from a huge range of areas. It is consistently being updated, and making sure that you're always using the most up-to-date data, that you understand when you update data, what changes are actually being driven by those updates. So if, for example, a national greenhouse gas inventory decides to change an emission factor for one class of livestock, what does that mean? What does that mean for your reporting? Is it going to go up? Is it going to go down? These are really important questions. And also how you're going to start doing additional sampling and feeding your measurements into the system, which I've mentioned before. Third part is the sustainability models and the research. So how are we actually going to take the existing models? How are we actually going to improve them? And really working this very, very fine line, I think, between what's cutting edge and exciting and what's actually robust and operational. And the cutting edge and the exciting is fantastic. We certainly need to be working on that. But how do you actually take that and turn it into something that we can turn the handle on every single day? And again, I think this from the remote sensing side, we're extremely fortunate to have SIBO Labs involved because that's their bread and butter. How do you take these things and turn them into operational products that are actually usable? And finally, this adding support required to drive action. And this is a really interesting piece from my perspective because it involves people. And people are more complex in many ways than many of the things we do in software code and modeling. And so how do you actually have the types of information coming through, not so it's just an information dump, but that people are able to interact with it and actually start to really think about how and why they're going to use this data to go forward. And then also start linking that from our side to what are the benefits? Are we going to link this to systems for saying, well, you could get government grants off here, or you could get a better interest rate on your your bank loan? What are the actual advantages of you being able to do this? I think this is a really fascinating part of driving the sustainability metrics forward. And with that, I will stop there. Thanks very much.
Thank you, Rob. Okay, so how does this project work? We're talking a 4-year timeline, and we're about here at the moment. Well, we're in the pilot phase, so 6-month pilot. We plan to kick off the 3.5-year project around the July timeframe. So what's been happening at the moment is there've been a bunch of interviews being done with from the UTS design school, so they're interviewing different producers to really understand the requirements about planning, how people currently do it. But they've even got to the stage of doing up wireframes of what a grazing planner could look like, and does it make sense? What would you like to see on it? What are we missing? And that's to really get that validation that we're on the right path there. So far, the interviews have been very positive. This seems to be a gap that a lot of producers want, to be able to get better tools for this planning. And so we've been understanding the current data set. Really, the livestock team have been breaking it out to understand the livestock growth via characteristics. They're starting to bring in other records now, like treatments, how that's affecting the livestock growth. There's a whole lot more to do on livestock alone. Then we'll be getting to that machine learning phase of being able to understand with all these diverse inputs. It's a lot more complicated than a simple linear regression. This is a tool that's going to be able to learn as the new data comes in. We're doing predictions and we're getting actuals. The actuals are going to make our machine learning smarter and smarter over time. We're looking, we never like promising stuff in the future, but this is a grant. So the grazing planner is scheduled for 2024. The scenario planner is 2025. The final year of the project is a longitudinal study where we're actually just running the simulation and tweaking it. So we can be able to really measure how the predictions are going versus the actuals, and really get that feedback with the producers to make sure that it's helping improve their business. If anyone's interested in getting involved, there's 2 areas. There's one that is the interviews with the design faculty, where we're really understanding the requirements. We're also looking for select farms around Australia, where we can do a really deep analysis. That involves, like, sharing your farm, the AgriWebb farm data with the researchers so they can actually see it. But it will mean that, the researchers will come out on farm, they'll bring drones and be able to get a high resolution map of your farm that they can provide to you as well. And we'll be using those as the ground truthing across Australia to be able to analyze and tweak the machine learning. So we've already started in the Molong area, where we've been working with some farms out there. I believe they're going to Wellington next week as well. So yeah, so there's options there for getting involved. Now, all up, there's about 36 people, including the government, the research institutes, industry, 36 people on this project. How do we make sure we're all working towards a common goal? So the ethos of the project is, this is not research in space. We are really motivated on getting this adopted by the industry. Like, we are having a commercialization path for all the research we are doing. And the idea is we want to get it in the hands of the farmers. One of the AgriWebb mottos is live for the farmer. So we're putting the farmer at the center of all this work. The other point is we want to make sure it's validated. We don't want the researchers to just be playing with the numbers in isolation. They need to get deep domain knowledge to make sure that the output is both relevant and accurate for the farmer. And 4 years is a long time. It's like a lifetime in startup life. So what we're talking about is iterative project. We're going to be releasing new benefits to the farmer throughout the project. It's not one big bang at the end. So this is a bit more detail on that first slide that Ash sent, showing about the existing partners. It shows you not just the partners, but also what's happening inside Foragecaster. So with the grazing planner and the scenario planner and the 4 major streams, which I talked about. So these are the people that have already been working so far. And we're looking at bringing on the UNE Smart Farm as well mid-year for the larger project. Okay, now we can get to the question time of the talk and answers even. To help give you some more inspiration, we have quite a few questions coming through already, but I'll leave it on this slide here. And this is a more detailed one of that first one I showed you about the research groups, but it shows you all the different parts that are happening. We also have these 2 minor streams as well. There's one group that's just purely focused on analyzing the weather to find the best weather sources, both for historical and for probabilistic forecasts in regional Australia. And another team that's focused on the data quality and governance, which leads us to our first question, which was anonymous. You can enter questions through the Q&A chat on your toolbar. How do you deal with data confidentiality between industry partners? I can take this. So when you sign up for AgriWebb, you are saying that you can send your data to AgriWebb. We won't share it with the third parties. So how do we actually get to work together on anything meaningful? What we did is we got this concept of a container. This is a technical term, but basically SIBO can type all their algorithms, all their software into a container, and then they give that container to us. So when we run it, SIBO doesn't know about the actual farm it's getting run on, but we're using their algorithms because we know the different farms, the people, the geolocations, and with the output of what the SIBO algorithms do, we can provide that to the researchers. Another point is all the data that we provide on the warehouse, we've encrypted all the IDs, so they don't match anything that happens in the AgriWebb product. So the researchers don't know which farm is which. Yeah, so this way we can hide the information between the industry partners and from the researcher, including the geolocations. All right, there's a next question is for Phil from Zoe. Can the software currently use the historical data of livestock movements to determine what pasture ground cover has been maintained and for how long the pasture is rested between grazers, showing seasonality, seasonally and rainfall layers? I'm going to get you off mute again.
Myself.
Here you go.
Thanks, Zoe. That's effectively already happening now within the grazing planner within AgriWebb. So we push data through an API directly into AgriWebb, and the user already can see effectively what their rest periods have been relative to pasture growth. So it's I suppose it's already happening to a large degree. That's correct.
Yeah. So here we have all this livestock data within AgriWebb, so we know. Because that's been the stumbling block in working at pasture growth rate prior. You don't know what was really grown unless you know what was actually eaten, or consumed. So with the livestock data, we have the actual paddock locations, the size, whether they're pregnant, the DSE or animal equivalents. Basically, we can understand the pressure that was eating down each of the paddock. From there, we can calculate its true pasture growth rate.
Yeah, probably just to quickly add to that, because we've got a couple of minutes. At the moment, we're also running, every time we see a little blip in growth, we can effectively accumulate that growth through a month, for example. So we can provide an independent estimate of what the pasture growth is. But every image that we estimate pasture biomass on may or may not have grazing pressure on it. So from an animal movement perspective, obviously, if it's that data's inside AgriWebb, you know about that. That doesn't account for kangaroo pressure or deer pressure or whatever. But what we can do is provide it over a fairly large area. So we can basically look at an individual farm and then look at the region around it and come up with some pretty sensible estimates of basically net primary production or net pasture growth, and which then that total grazing pressure can be put on top of in terms of pasture utilisation.
All right. The next question also from Zoe. Maybe it's a different Zoe, same Zoe. Question: how many months in advance are you seeking to lay the climatic data for forward decision making on feed on hand and animal conditions weight? It's a good question. So the seasonal forecasts go out to 6 months from the different providers. So that would be where we're getting that information from. Regarding planning, from the farmer's perspective, it differs quite a lot. And a lot of it could be based on their location, how often they see the animals. In the south, they might be doing movements every day or two. They might be planning to 2 weeks, they might be planning to a month. Up in the north, they may be planning from 6 months to a year, because they see the animals a lot rarer. So the grazing planner will take both those scenarios into account, where you could set the different time periods. So we'll have to do some homework on how do we work out the different weather scenarios when you go past 6 months, because this doesn't get provided. So that will be, statistical analysis based on how weather has performed in the past for a similar type of year. But end of the day, we're not working out the exact millimeters it's going to be. What we're working out is, what does a dry season look like? What does a wet season look like? So we can plan accordingly. Anything else to add? Anyone on those? Sounds right. Next, is the team working on farms that do adjustment growers that have grazing partners and don't own livestock? At the moment, we haven't picked any particular farms for the deep analysis that are just purely growers, but technically there are a lot of farms that do that already, so it's in the data warehouse, because at the grazing planner stage, we are focused on the grazing management. So it's about moving the animals between the paddocks. When we get to the scenario planner stage, then that will start to bring in the different financial aspects of the planning as well. So it's something we can look at over time. Are the grazing rotations covered per mob? Yes, so that's one of the things that the design group have been asking for the interviews, and that's, how do people like to do their rotations? So it may be that you select a bunch of mobs or a age class or a management group, say all my heifers or a subgroup of them, and you'll pick a bunch of paddocks, and then you'll say, given this, give me the most optimal grazing plan for that, on where they should move and how long they should be in there. Now, that's just a guide, of course. You can go in and tweak it. You could just ignore it and build it from scratch if you want, but it does allow for that forward planning that can help you be better prepared for the decisions on farm. One of the things we learned was some farmers thought that, oh no, we can't do any planning in the future because it might all change in 2 weeks. And then so we ask, so what actually changes? Or it might be wet or dry. And then we ask, oh, but you know what you're going to do if it's wet. You know what you do when it's going to dry, when it's dry. And then they thought, oh yeah, we can actually plan that. If we make a scenario that says wet, we know what we're going to do if it's wet. And that allows us to better plan to minimize risk. Okay, one for Phil, for Kasmin. Is a license for smaller holdings on the horizon? I looked at adding the paddock level, but the smallest level was 1,000 hectares.
Yeah.
Most properties where I live are about a quarter of that.
Yeah, so it's actually we've got lots of producers that have less than 1,000 hectares there, Kasmin. It's that really relates to the minimum subscription level. So at the moment, our minimum annual subscription for the pasture key service is $1,000 a year. So it's just a matter of how big your farm is and whether that $1,000 is going to be a value proposition for you. So at the moment, with sort of economies of scale, that minimum $1,000 a year is sort of a point where we just sort of, it's dealing with the transaction costs of onboarding clients and so forth. So if it's if $1,000 is not too much, if you've got 500 hectares or 250 hectares, we can certainly provide a service.
Great. Another one, this one's from Emma. ground cover data question. Which geographical regions is the data captured from? It is pretty well distributed Australia-wide. Are there regions of significant lack of data?
Emma, you might be, I'm sure they're talking about ground cover specifically or the pasture biomass data, but we've been working very closely with state agencies with the ground cover, and Peter Scarth is one of the developers of the Joint Remote Sensing Research Program ground cover data, which is being mostly done Australia-wide. There's about 4,000 or 5,000 field sites across Australia with that. With our pasture biomass predictions, as I said, we're up to about 6,000 odd pasture sites now. Each site is a 50-metre transect with a minimum of 5 quad rats on it, either visual or pasture cuts. We're doing pretty well in terms of spread. We've got a lot of collaboration there across Australia. Probably the main area, the main gap, I would basically say, is sort of areas like Western New South Wales in the blue bush, sort of salt bush country. We've had people like Dione Walsh and others doing a lot of work in sort of the rangelands in Northern Territory and in WA, sort of southern rangelands. So it's really just a matter of continuing to pick off those areas where we've got data gaps and continuing to fill them to improve the quality of the model in those areas. So it's a continuous process.
Okay. Next question is from Zoe. Are you already working with intensive dairies who are using very detailed individual livestock details? This came up in quite a few of the interviews, saying that the dairy people are, they do the planning very well. Then there's a lot we can learn from dairy. So yeah, we are looking to see, the different tools available that the dairy teams have been using. There's, a lot of differences between the grasses that the dairies are working on, but the methodology, there's going to be similarities in that we can bring across for the grazing planners. Another question, how many months forward? I think we've done that one already, isn't it? How many months in advance are you seeking to layer climatic data? Yes, so that's one of those variable. All right, I think that's it. That's where we're past time now. That's all the time we have questions for now. Feel free to reach out to us if you have any questions or want to be involved in the project. You can contact AgriWebb on any of the support channels, and we'd love to hear from you about what you thought about the project, or if you'd like to be involved and learn more. All right. Thank you all for your time.
Thanks, everyone.
See you soon. Thanks, Kenny.